using the rational zero theorem to solve polynomial equations. Answer the following questions about the equation below. X cubed minus 5x plus 2 equals 0. Part A, list all rational roots that are possible according to the rational zero theorem. So to do this, we're going to take all the factors of the constant term and divide them by the factors of the leading coefficient. Now the constant term is 2, and the factors of 2 are 1 times 2 and negative 1 times 2. The leading coefficient is the number in front of the x cubed, and that's a 1. So the factors of 1 are just 1 times 1, and then negative 1 times negative 1. Now if we were to set this up as a division problem, I have 1, 2, negative 1, and negative 2. And then a 1 and a negative 1 in my denominator. So I'll go ahead and divide these. 1 divided by 1 is just 1. 2 divided by 1 is 2. Negative 1 divided by 1 is negative 1. And negative 2 divided by 1 is negative 2. Then I have 2 divided by 1 is 2, but that's already listed. And 2 divided by negative 1 is negative 2, and that's already listed. Now I have a negative 1. Negative 1 divided by 1 is negative 1. And that's already listed, so I won't list that. And then negative 1 divided by negative 1 is a positive 1, and that's already listed as well. Now I have the negative 2. So negative 2 divided by 1 is a negative 2, and that's listed. And then negative 2 divided by negative 1 is positive 2, and that's also listed. So my only possible rational solutions are 1, 2, negative 1, and negative 2. Part B. Use synthetic division to test several possible rational roots in order to identify one actual root. So my possible solutions were 1, 2, negative 1, and negative 2. So I'm going to use synthetic division to test each of these roots. First I'll test 1. And my problem was x cubed minus 5x plus 2. So the numbers that go next to that box with the 1 in it are 1. And then I need to have an x squared term, and I don't, so I'm going to put a placeholder of 0, and then I have a negative 5, and then a positive 2. Now I'll just do my synthetic division. Bring down the 1, and then 1 times 1 is 1. Add 0 plus 1 is 1. Multiply again. 1 times 1 is 1. Negative 5 plus 1 is negative 4. 1 times negative 4 is a negative 4, and negative 4 plus 2 is a negative 2. In order for this to be a root, the remainder must be 0. The remainder is not 0, so I know that 1 is not an answer. It's not a solution to my problem. So now I'll test 2. And again, I'll use the same coefficients. And I'll divide. Bring down the 1. So I have 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. Negative 5 plus 4 is a negative 1. Negative 1 times the positive 2 is a negative 2. And 2 minus 2 is 0. Since I have a 0 in my remainder box, I know that 2 is a solution to my problem. So one actual root is x equals 2. And my quotient is x squared minus 2x minus 1. And I got the x squared because I just subtracted 1 from the highest exponent of my original problem. Use the root from part B to solve the equation. I already found one solution to be 2. Now I'm going to find my other solution. In order to do that, we're going to use the quotient that we found in part B, which is x squared plus 2x minus 1, and set it equal to 0, and solve for x. Now this quadratic cannot be factored into two sets of binomials. So in order to solve for x, we're going to use the quadratic formula. So I have the quadratic formula written on the screen. So I'm just going to plug in my numbers for a, b, and c and solve. So we have a negative b, so that will be a negative 2 plus or minus the square root of 2 squared minus 4 times a, which is 1, times c, which is the negative 1, divided by 2 times 1. And we can go ahead and simplify this. So we get the square root of 4 plus 4, since negative 4 times 1 times negative 1 is a positive 4. And then divide that by 2. X equals negative 2 plus or minus the square root of 8 over 2. And we can simplify the square root of 8 because the square root of 8 is the same as the square root of 4 times the square root of 2, which is 2 square root 2. Lastly, we can simplify by reducing each coefficient by the denominator, which is 2. So we have negative 2 divided by 2, which is negative 1, plus or minus, and then 2 divided by 2, which is 1. So we just are left with the square root 2. And these are my solutions. So my answers are 2, which I already found in part B, and then negative 1 plus square root of 2, and negative 1 minus square root of 2. So these are my 3 solutions and answers to my problem.